Have you ever looked up at the night sky and wondered, why does it all look so dark and yet so full of light? Our universe is painted with colors, but most of them are invisible to our eyes. Tonight, we'll wander slowly into this mystery, drifting from the black backdrop of space into the hidden rainbows written in starlight. This is not just science, it is a story, a lullaby of light across billions of years. So close your eyes if you wish, let the mind drift and remember, you are part of this cosmic painting too. And before we dive in, if you find comfort in these journeys, don't forget to subscribe, so you can always return to this quiet corner of the cosmos. Why the universe is not truly black. When we look up at night, the first thing we see is darkness. But that blackness is not empty. It is filled with faint whispers of light, too weak for our eyes to catch. Ancient starlight, stretched across space, hides just beyond our vision. This puzzle is called Olber's paradox. If the universe has so many stars, why isn't the sky ablaze? The answer is hidden in distance, in dust, in the fact that light can be swallowed by time itself. Space is black to us, but only because we are small eyes in a vast, unfinished picture. If our eyes were tuned differently, the night would glow. Radio waves would hum across the sky. Microwaves from the Big Bang would paint it faintly golden. Even the infrared warmth of cold dust would shine like embers scattered in the dark. So the blackness above is not a void, it is a veil. Behind it is color beyond imagination. What looks like nothing is actually everything. And when you remember this, the silence of night feels less lonely. You realize the black sky is only black because we haven't yet learned to see with the universe's full palette, the first human eyes that looked up at night. Imagine the first people who looked into the stars with no lamps, no cities, no noise. Their eyes, sharper in darkness than ours, saw the Milky Way stretched like a river of fireflies. To them, the universe was alive with motion and glow. They gave names to stars not just for guidance, but because the sky spoke in symbols. A red star was a hunter's fire, a blue star was a blade. They wove stories because to them the sky was more than dots. It was a canvas of meaning. We often forget how much darker the nights once were. Without pollution, the stars revealed their true brilliance. The sky was never truly black. It was salted with diamonds, brushed with faint milky clouds, full of mystery. Ancient eyes also noticed the differences. Some stars glowed steady, some flickered, some burned reddish, some white. Without knowing physics, they already understood that color in the sky carried secrets. And even now, when we step away from cities into deep wilderness, we can almost see what they saw. The sky becomes ancient again. It whispers in colors that we have nearly forgotten. Why colors in space are hidden from us. We humans see only a narrow band of light, the visible spectrum. Red to violet, that's our slice of the cosmic rainbow. But outside this slice lies a universe of hidden colors we can't perceive. A star emits not just visible light, but infrared, ultraviolet, radio, X-rays, and more. To our eyes, these are invisible. To a telescope, they are worlds. This is why astronomers often show us false color images. They are not lies, but translations of light we cannot otherwise see. Think of it like listening to a symphony through a door, and we hear only a fraction of the instruments. The universe is performing the full piece, but our ears and eyes are limited to a tiny corner of the melody. That's why the pictures from Hubble or James Webb seem unreal. Glowing clouds in greens, blues, and purples. They are the real data, shifted into colors we recognize. The sky hides its palette, and we need machines to show us the truth. So what we call black space is simply our blindness. The universe has always been painted. We are just learning how to open our eyes. The mystery of invisible light beyond our sight. When scientists built telescopes to see beyond visible light, they found surprises waiting everywhere. Radio telescopes showed galaxies stretching like spiderwebs. Infrared revealed star nurseries hidden in dust. X-rays showed violent storms near black holes. Suddenly, space was no longer silent, it was roaring. Every color of invisible light tells a different story. Radio waves travel the farthest, carrying whispers from the dawn of galaxies. Ultraviolet betrays the hottest, youngest stars. X-rays and gamma rays come only from cosmic violence. Exploding stars, colliding objects. It is strange to think that our eyes evolved to see just the light of our sun, useful on Earth, but blind to most of the cosmos. We were never designed to see the whole truth. And yet, with instruments, we borrow new eyes. Each telescope is like learning a new language of color. Together, they give us a richer, stranger universe than we could ever imagine with sight alone. The mystery remains. If so much is invisible, how much more lies beyond even our machines? The thought is humbling. The universe may be painted in shades no mind has yet named. The secret language of light. Every star, every galaxy, every cloud of gas leaves its fingerprint in color. Physicists call it a spectrum, a rainbow broken into fine detail. Within that rainbow are tiny gaps, tiny lines like notes in a secret song. Those lines reveal what an object is made of. Hydrogen glows red, oxygen glows green, helium sings in blues and purples. By decoding these colors, astronomers can tell the chemistry of stars a million light-years away. Light also reveals motion. When galaxies race away from us, their light stretches into red. When they move closer, it shifts blue. This Doppler effect is how we know the universe is expanding. Color is not just beauty, it is a message. It's almost as if the cosmos is talking to us in code, and we are slowly learning to read it. The universe doesn't shout, it writes gently in beams of light across unimaginable distances. And when you think about it, every photon that hits your eye tonight may have traveled for millions of years, carrying a color, a story, a secret. Light is the oldest messenger in existence, and it never stops speaking. Red, the oldest whisper of the universe. Red is the color of age in the cosmos. When light travels across great distances, it stretches, losing energy, and what once was blue or white slowly turns red. Astronomers call this redshift. To our eyes, red in space is not just a hue, it is time made visible. Stars that glow red are often the elders. Red giants like Betelgeuse swell at the end of their lives, breathing their last warmth across space. Their soft glow is slower, calmer, more fragile than the burning blue stars. They remind us that even in the universe, age carries a different kind of beauty. Gas clouds, too, when lit by newborn stars, often glow red. Hydrogen, the most common element, releases its light in crimson tones. The Orion Nebula, glowing faintly red, is a nursery of stars. Within its haze, new suns are born under a veil of cosmic red velvet. Even the very fabric of the universe is red. The oldest light, the cosmic microwave background, has stretched so far over billions of years that it has drifted into red and then beyond red, into microwaves we cannot see. But that story began in fire, cooled, and left us a red shadow. And so whenever you see a red glow in the heavens, you are not just seeing color. You are seeing history stretched thin, the universe itself whispering across the longest of distances. Blue, the color that runs away fastest. Blue light is the opposite of red. It is young, it is quick, it is restless. Blue stars burn with a ferocity that shortens their lives. They shine brighter, hotter, and die faster. To see a blue star is to catch a life lived at full speed. Our own sky is blue for the same reason. Shorter wavelengths scatter more easily. Sunlight bounces through our atmosphere, and blue runs wild across the day. In space, this scattering happens in clouds of gas, turning some nebulae into luminous, shimmering blue pools. There is something strange about blue. It fades the fastest. That is why distant galaxies look red. Blue cannot survive the journey. It is the sprinter's color, dazzling at first, but too quick to last across the great road of the universe. Blue also carries secrets about youth. When astronomers see a galaxy glowing blue, they know stars are being born within it. Blue is the flare of beginnings, the rush of energy when something new bursts into being. It is a color of promise, but also of impermanence. Blue is the fire that will not last, a reminder that brilliance often burns brightest just before it fades. Yellow and gold, suns that shine like coins. Our own sun is not truly white, nor is it red. It is golden, a soft yellow glow, steady and kind. From Earth, this is the color of warmth, of harvests, of life itself. The gold of the sun is the color of survival. Yellow stars like our sun are middle-aged. They are stable, burning hydrogen slowly, neither racing to die like blue giants nor flickering faintly like red dwarfs. They sit in a balance, glowing in a way that makes planets like Earth possible. Life, as we know it, seems to bloom best under gold. This golden glow is also deceptive. From space without atmosphere, the sun looks more white than yellow. It is our skies that tint it with warmth. Yet the feeling remains. Golden stars are the hearths of galaxies, glowing with just the right fire. Astronomers often describe the habitable zone around such stars as the Goldilocks zone. Not too hot, not too cold, a golden middle ground where oceans can remain liquid and life has a chance to grow. Yellow stars are cosmic hosts, and their color is an invitation. Every golden sunset we see is not just Earth's beauty. It is the echo of our place around a star that glows in balance, one of countless golden suns in the night. White, the illusion of every color together. When light carries every color, we see it as white. To our eyes, this is the sum of all rainbows compressed into one. Many stars appear white, but inside their glow all the hues of the spectrum are hidden. White dwarfs are one of the strangest stars. They are remnants, the final breath of a medium star, small, dense, glowing white, not because they burn fuel, but because they are still cooling. They shine with ghostly persistence, like embers that refuse to go out. Our sun, too, if seen from far away, would appear almost white. And when you look at the Milky Way on a dark night, the hazy band glows pale and white. But remember that whiteness is made of billions of stars, each with its own unique color, blurred together. White in the cosmos often feels like mystery. It is light without distinction, as if the universe is holding back its secrets. Only with tools can we split that white into its spectrum and discover the truth of what lies inside. To see white in the universe is to see a mask. Behind it, every other color waits, blended together, waiting to be revealed. Black, the silent background of infinity. And then there is black, the most misunderstood color of all. To us, black feels like emptiness. But in the universe, black is never truly empty. It is a canvas for everything else. The black of space is not absence, it is distance. It is the stretching of light until our eyes can no longer see it. It is dust blocking starlight. It is shadows cast across eternity. Yet in that blackness, galaxies move, stars burn, particles hum, with energy unseen. Black holes, too, the darkest places, are not voids, but dense wells of gravity. They swallow light, bend time, and yet at their edges glow with the brightest colours as matter falls inward. Black is the silence that makes the music of the universe louder. To sleep under a black sky is to rest beneath the universe's deepest curtain. It is humbling, and it is calming. Black gives the stars their brilliance, the galaxies their shapes, the nebulae their contrast. Without black, there is no canvas to paint upon, and so black is not nothing. It is the backdrop of infinity, the quiet frame that allows all colour to be seen. It is the reminder that darkness is not always absence. Sometimes it is presence too. Why stars glow in different colours? When we gaze at the night sky, it seems like all stars are the same, tiny points of white. But if you look closer, or let your eyes adjust long enough, you begin to see something different. Stars are not all the same shade. Some lean red, some gold, some faintly blue. Their colours carry secrets about their age, their temperature, their very life cycle. A star's colour is really a measure of its heat. Just like iron glows red when heated and turns blue-white when burning hotter, stars reveal their temperatures through their hues. Cool stars glow red, warm stars glow yellow, and the hottest blaze blue. It is nature's thermometer written in light. But there's more than just heat. Colour reveals size, speed of burning, even destiny. A red dwarf may live for trillions of years, while a blue giant burns out in just a few million. The colour is not just surface beauty. It is a signature of time. To the naked eye, most differences are subtle, washed out by distance and atmosphere, but once you know, you can't unsee it. The universe glitters not in uniform white, but in a secret rainbow spread thin across eternity. And perhaps the most magical thought is this: every star we see has its own story, and its own colour is the opening line. Red dwarfs, the gentle fires of longevity. Among the most common stars in the universe are the red dwarfs. Small, dim, cool, they may not draw attention in the sky, but they outnumber all the brighter stars we admire. The quiet ones are often the most abundant. Red dwarfs burn their fuel slowly, stretching their lives into trillions of years. Compare this with our Sun, which may live only 10 billion years. Red dwarfs live so long that none of them have died yet, not a single one. Every red dwarf that has ever formed is still burning somewhere right now. Their faint red glow might look unimpressive to us. You wouldn't see them with the naked eye from Earth. And yet, because they live so long, they may be the keepers of the universe's most enduring stories. If life exists elsewhere, many scientists believe it may orbit a humble red dwarf. Imagine civilizations born under dim skies, their sun always faint but steady. No dramatic sunsets, no scorching heat, just a calm red horizon lasting longer than human imagination can grasp. Red dwarfs remind us that greatness isn't always brightness. Sometimes it is endurance. Sometimes it is the quiet, patient glow that never fades. Blue giants, the short-lives that burn fast. If red dwarfs are patient, blue giants are the opposite. They are massive, brilliant, and ferocious. These stars blaze at temperatures of tens of thousands of degrees, pouring out light so intense it can outshine thousands of suns. But their brilliance comes at a cost. Blue giants live fast and die young. While our sun might survive for billions of years, a blue giant may last only a few million before collapsing, exploding, or becoming something stranger. They are cosmic fireworks, dazzling, breathtaking but brief. Their light travels across galaxies, reaching us with a kind of urgency. Blue light, the highest energy visible to us, feels sharp, crisp, almost electric. To see a blue star is to glimpse a life at full throttle, one that cannot last long. These stars often end their lives in supernovae, scattering heavy elements into the cosmos. Iron, gold, even the calcium in our bones was once forged in their violent end. Without the short lives of blue giants, we would not exist. Their death is our inheritance. There is poetry in knowing that beauty often burns brightest just before it disappears. Blue giants are reminders that brilliance and brevity are sometimes the same story. Golden stars like our sun. And then there are stars like ours, steady, golden, moderate. They don't dazzle like blue giants, nor hide like red dwarfs. They sit in the middle, the perfect balance of power and patience. Our sun is one of these golden stars, a quiet guardian of life. Golden stars burn hydrogen steadily, neither too fast nor too slow. They create conditions where planets can orbit peacefully for billions of years. Their glow is not dramatic, but reliable. This reliability may be the rarest gift in the cosmos. From Earth, the sun's golden color is partly an illusion. Our atmosphere scatters the light, giving it warmth. But the feeling remains. Gold is the color of life. Without it, there would be no oceans, no trees, no us. When astronomers search for life in other galaxies, they often look for golden stars. They may not be the most common, but they are stable enough to host planets like Earth in the so-called Goldilocks zone. Not too hot, not too cold. Every sunrise is a reminder that we are orbiting a star just right, not too fierce, not too faint, but balanced, glowing, and golden. White dwarfs, the cooling embers of old suns. Not all stars end in fire and fury. Some fade quietly. When a star like our sun uses up its fuel, it does not explode. Instead, it shrinks, compressing into a white dwarf, a star no bigger than Earth, yet with the mass of a sun. White dwarfs shine not because they burn, but because they are still hot, slowly cooling over billions of years. They are the embers of stars, glowing not with fire, but with memory. Imagine a coal, still warm after the flames have died, holding light long after its prime. They are strange objects. A teaspoon of white dwarf matter would weigh tons. Gravity crushes their atoms so tightly that they become something between matter and energy, a form of cosmic crystal. Over time, they may cool so much that they fade into darkness. Black dwarfs, stars that shine no more. Yet none are old enough to have cooled completely. Every white dwarf that has ever formed is still glowing somewhere in the universe. The night sky is filled with these tiny, persistent ghosts. To look upon a white dwarf is to look at the memory of a sun. It is a reminder that endings need not be violent. Some fade gently, carrying their light into the quiet of eternity. Neutron stars, light that bends with gravity. Some stars end quietly, some in brilliance, and some in extremes. When a massive star dies, its core collapses into a neutron star, a city-sized sphere heavier than our sun. In this collapse, light itself seems to bend around it. Neutron stars often glow faintly white or blue, but their true colors lie in radiation beyond our eyes. They beam radio waves, X-rays, even gamma rays, spinning like lighthouses in the dark. Astronomers call these pulsars, blinking in rhythms as steady as heartbeats. What makes them extraordinary is their density. A teaspoon of neutron star matter would outweigh mountains. Within them, atoms no longer exist as we know them. It is matter crushed into pure strangeness, and yet they still shine. Their colors are hidden to us, yet telescopes reveal bursts of invisible light, patterns across space like Morse code from the edge of physics. They are the strangest stars we can see, glowing with the echoes of catastrophe. To think, every flash from a pulsar is the heartbeat of a dead star, still pulsing across the galaxy, still reaching us through time and distance. Why galaxies look milky and misty. From Earth, the Milky Way appears as a faint cloud, stretching across the night. Ancient cultures thought it was spilled milk, a trail of fire, or the path of souls. But what looks like mist is not mist at all. It is billions of stars blurred together. Galaxies glow because of their countless suns. From afar, their colors blend into hazy light, bluish in spirals, reddish in older ones. To us, they appear as soft smudges, but inside, each smudge holds entire worlds. The word galaxy itself comes from the Greek for milky, named for this faint band in our sky. And the truth is, every point of mist we see in telescopes is another Milky Way, another island of billions of stars. Their colors shift with their populations. Young galaxies shimmer blue, ancient ones glow red. The mistiness is distance playing tricks. What is sharp up close becomes dreamy across the void. Looking at a galaxy is like looking at a lantern far away in fog. You don't see the parts, you see the glow. And in that glow you feel the weight of infinity. Spiral arms and their blue hues. Spiral galaxies are among the most beautiful sights in the universe. Their arms curl outward like seashells, and those arms often glow blue. Why blue? Because that is where the youngest stars are born. In the spiral arms, gas and dust collapse to form new suns. These newborn stars are massive, hot and blue. They shine with such intensity that they dominate the spiral's color, even though they will live only briefly. Meanwhile, older stars drift in the center, glowing red or yellow. This is why spirals have contrasting shades in our red cores surrounded by blue arms. It is a balance of age and youth in one galaxy. From Earth, when we see pictures of galaxies like Andromeda, the blue arms almost look painted on, yet they are real. Swirls of stellar nurseries, rivers of creation, still flowing billions of years after they began. Spiral arms remind us that galaxies are not static. They are alive, constantly renewing themselves. And in their blue glow, we glimpse the birthplaces of stars yet to be named. Red galaxies, home of the ancient stars. Not all galaxies shine blue. Some glow red, not because they are burning hotter, but because they are growing older. Red galaxies are home to ancient stars, long past their youth, glowing faintly across the void. These are elliptical galaxies, massive and rounded with little dust and gas left. They have stopped making new stars. What remains are the older suns, red, dim, steady. Their color is the color of endings, not beginnings. To astronomers, a red galaxy is a fossil. It is a record of a time when stars were born in great waves, followed by silence. No new light is coming, only the long glow of the past. There is beauty in this too. Red galaxies are the resting grounds of creation, places where the universe's energy has slowed. Their color is a reminder that not all things blaze forever. And yet, even in their quiet, they hold trillions of stars. They are not dead, only ancient. Their red glow is not absence, but memory. The green valley galaxies nobody talks about. Between the blue spirals and the red ellipticals lies a rare, mysterious group, the Green Valley galaxies. They are in transition, shifting from youthful star-making to quiet age. Their color is not literal green, but a balance between blue light of new stars and red light of old. Astronomers puzzle over them. Why does a galaxy stop making stars? Sometimes gas is stripped away by gravity. Sometimes it is heated until it cannot form new suns. The result is a galaxy caught between life and stillness, glowing in this strange middle shade. They are rare, fragile, fleeting. A galaxy does not stay in the green valley long, only a cosmic moment before it slips fully into red. Catching one is like seeing twilight in the heavens, a moment between day and night. In these galaxies, the story is bittersweet. They are neither young nor old, but pausing on the edge. The green valley is not vibrant growth, but the last echoes of it, fading into silence. Perhaps that is why they feel so human to us. They are galaxies in transition, caught between what they were and what they will become. When a galaxy glows infrared in the dark, to human eyes, most galaxies look pale, bluish, or reddish. But through infrared telescopes, many reveal an entirely different glow. Dust, too cold to shine in visible light, radiates softly in the infrared, a warmth our eyes cannot see. Infrared galaxies are often hidden factories of stars. Dusty clouds block their light in visible wavelengths, but when we shift our vision, we see their hearts blazing with newborn suns. They glow in a reddish-orange haze, like embers burning behind smoke. Some of the brightest galaxies in the universe are invisible to us until we use infrared eyes. They are called luminous infrared galaxies, and they hide more starlight than entire visible galaxies. They are ghosts that only appear when we look differently. It makes you wonder how much of the universe is invisible simply because we lack the right senses. What looks like blackness could actually be alive with warmth, pulsing just beyond our reach. Infrared galaxies remind us that appearances deceive. What looks quiet may be brimming with life, waiting for us to learn how to see it. The rare ultraviolet beacons. Just as some galaxies glow in infrared, others shine brightly in ultraviolet. These are rare, young galaxies full of hot, massive stars that pour out energy at wavelengths far beyond human sight. To us, they are almost invisible. To telescopes, they blaze like torches. Ultraviolet light does not travel far. It is easily absorbed by dust and gas. That's why these galaxies are precious to astronomers. They are snapshots of the universe's youngest, most energetic places where stars are being born at furious rates. From Earth, our atmosphere blocks most ultraviolet light, protecting us from its harmful effects. But from space telescopes, the sky is alive with it. Clouds glow, clusters pulse, galaxies blaze in violet fire our eyes cannot register. The strange thing is, ultraviolet beacons tell us about beginnings, about the early days of galaxies. To see them is to catch creation in motion, sparks flying as the universe builds its architecture. They are rare, fleeting, but powerful. And in their unseen violet glow, we glimpse the restless youth of the cosmos itself. Why nebulae are the painters of the sky? If galaxies are the grand canvases, nebulae are the brushstrokes. They are clouds of dust and gas, stretched across light years, glowing in colors so vivid they look unreal. They are where stars are born and where stars return when they die. Nebulae glow because of energy. Sometimes starlight excites their gas, making them fluoresce in red or green. Other times, dust reflects light, turning them soft blue. Each nebula is like a painting with a different palette, drawn not by hand, but by physics. The Orion Nebula, visible even to the naked eye, glows with a faint reddish hue, hydrogen gas lit by newborn stars. The Ring Nebula, on the other hand, glows greenish-blue, the final breath of a dying sun. In telescopes, nebulae look like watercolors spilled across black paper. Wisps of red, swirls of purple, streaks of emerald. They are as much poetry as science. Cosmic clouds that remind us the universe is not grey, but endlessly colored. Nebulae are not just objects, they are transitions. The colors we see are the pigments of creation and destruction, swirling in endless cycles, the red glow of hydrogen clouds. Hydrogen is the simplest and most common element in the cosmos. When it is excited by starlight, it releases a deep red glow. This is why so many nebulae shimmer with crimson light. It is the universe's favorite ink. The Balmer series, as scientists call it, is the fingerprint of hydrogen. It is a steady shade of red, unmistakable, stretching across star-forming regions like Orion or the Eagle Nebula. Wherever you see this red, you know stars are being born inside, and to human eyes this glow looks soft, diffuse, like smoke lit by fire. But in reality, it is the color of atoms colliding, absorbing energy, then releasing it again, a dance billions of years old, happening in silence. This red is not just beauty, it is life itself. Without hydrogen clouds glowing, collapsing, igniting, there would be no stars, no planets, no us. That faint crimson across the sky is the color of beginnings. Every time you glimpse it, remember, you are seeing the rawest, most ancient story the universe tells. How light is born from nothing but gas and gravity. The blue reflection of starlight on dust. Not all nebulae glow by themselves. Some shine only because they reflect the light of nearby stars. These are reflection nebulae, and their color is almost always blue. But why blue? Because dust scatters blue light more easily than red. The same reason our daytime sky is blue. When starlight passes through a dusty cloud, the red slips away, and the blue bounces toward us. The result is a soft, ethereal glow, as if the dust itself has turned into luminous fog. The Pleiades cluster, with its surrounding blue haze, is one of the finest examples. This scattered blue is gentle, dreamlike, not harsh. It feels like moonlight on water, delicate, fleeting, a color born of reflection, not fire. It is the universe's way of painting with shadows. Scientists value these nebulae too. Their colors reveal the size and composition of the dust grains, the structure of the cloud. In studying them, we learn not just about beauty, but about the very stuff that will one day form planets. To see a blue reflection nebula is to witness starlight caught like smoke in the wind, glowing, shifting, alive only as long as the star beside it continues to shine. Greenish oxygen in the depth of space. In some nebulae, you will notice a strange greenish glow. It almost looks unnatural, as though space were lit by emerald fire. This comes from oxygen. Not the kind we breathe, but atoms stripped bare and energized by starlight. The Ring Nebula, the Helix Nebula, both shine with this eerie green at their centers. What you're seeing is light from oxygen atoms releasing energy after being hit by ultraviolet radiation. It is a signal of dying stars, gas expanding outward, glowing briefly as it cools. To our eyes, the color can feel haunting. Green is rare in the natural night sky, so when it appears, it carries mystery. It looks more like a painter's stroke than a natural phenomenon. Yet it is simply physics written in color. Oxygen is a bridge element, forged in stars, carried into space by their deaths, and eventually breathed by creatures like us. When we see green in space, we are seeing the same element that fills our lungs, glowing light years away. That shade is a reminder. The very air that sustains us was once the luminous breath of stars, the purple mix that feels like dreams. Sometimes nebulae shimmer in violet or purple hues, a blend of hydrogen's red and helium's blue. It is not a single element speaking, but a chorus. The mixture feels dreamlike, softer than either color alone, like twilight turned into paint. The Trifid Nebula is one example. It glows with swirls of red and blue, blending into purple clouds that feel like a watercolor painting. These regions are often where new stars are forming, chaos and beauty woven together in silence. Purple has always carried symbolic weight for humans, the color of mystery, of spirit, of in-between spaces. Perhaps that's why when we see it in the sky, it feels so deeply resonant. A color halfway between the known and the unknown. In truth, our eyes are not very good at seeing purple in the night sky. It is faint, often exaggerated in telescope images, but the feeling it evokes, the sense of something just beyond reach, is very real. Purple in the universe is a dream we only partly glimpse, a reminder that not everything can be fully seen, only imagined. The black silhouettes of dark nebulae. Not all nebulae shine. Some hide the light. Dark nebulae are thick clouds of dust and gas that block the stars behind them, creating inky silhouettes against the galaxy's glow. They are not empty. They are heavy with matter, waiting to form new stars. The Horsehead Nebula is perhaps the most famous. Against the red background of Orion, it stands as a black cutout, a void in the middle of brilliance. To the eye, it looks like absence. To science, it is potential waiting to ignite. Dark nebulae remind us that color is not always presence. Sometimes it is shadow. They are the blank spaces of the universe where light cannot pass, where mystery gathers in silence. If you imagine floating near one, you would see nothing but thick blackness like a cosmic fog, and yet hidden within stars are being born, quietly kindling before they pierce the darkness. The black of these nebulae is not final, it is the pause before the next chapter of light begins. Why Mars glows rusty red. Among the planets, Mars is unmistakable. In the night sky, it shines with a faint reddish light, easily seen even without telescopes. This is why ancient civilizations called it the planet of war, a red ember wandering among the stars. The color comes from iron oxide, rust. The surface of Mars is coated in dust, rich with iron, and when it reacts with trace oxygen, it forms that distinctive red hue. Mars is, quite literally, a planet covered in rust. Seen through a telescope, Mars can look orange, rusty, even golden, depending on the season and the angle of sunlight. Dust storms sweep across it, sometimes cloaking the entire world in a reddish haze. This redness is more than just surface. It has shaped how we imagine the planet, fiery, harsh, yet inviting exploration. Every time it appears in the night sky, we are reminded that color shapes our myths as much as science. Mars glows not because it burns, but because it carries the scars of a long dry history, written in iron and dust. The deep blue of Neptune and Uranus. Farther out, the outer planets offer their own colors. Neptune and Uranus shine with deep blues and aquamarines, so striking they almost don't look real. Their colors come from methane in their atmospheres, which absorbs red light and scatters blue. Uranus glows a pale turquoise, soft and misty. Neptune, darker and richer, almost sapphire. They are the jewels of the solar system, cold and distant, but impossibly beautiful. Their shades make them feel more like paintings than planets. Through telescopes, these colors are faint, but spacecraft images confirm their striking hues. Unlike rocky planets, their atmospheres blend gases into soft gradients, smooth as brushstrokes on a canvas. These shades remind us that not all worlds are grey or brown. Some are colored like oceans we cannot touch, blue seas we can only imagine from afar. To gaze at Neptune or Uranus is to wonder what it would be like to stand under a sky tinted that same blue, a sky no human has ever seen, but one painted for us in silence across the solar system. Earth, the pale blue dot in the dark. From space, Earth does not look like continents or nations. It looks like a fragile blue bead glowing softly in the vast blackness. Carl Sagan called it the pale blue dot, and that phrase has stayed with us ever since. The blue comes from our oceans and our sky. Water absorbs red light, leaving the planet dressed in azure. The atmosphere scatters blue wavelengths, making the surface glow like a jewel. Together they turn Earth into something unique among the planets we know. But the color is not constant. Sunsets turn it gold, auroras paint it green, storms cover it in white swirls. Earth is not a static hue, but a living, shifting canvas, its colors breathing with weather and life. Seen from afar, Earth's blue is faint, yet it carries meaning. It is the color of water, the color of life. Out of billions of stars and planets, our tiny world is distinguished not by size or brightness, but by this shimmering shade. And every time we look at it, even in photographs, it reminds us. Beauty in the cosmos is not just distant. Sometimes it is the ground beneath our feet. Jupiter's bands of browns and whites. Jupiter is a giant unlike any other. Its swirling clouds form bands across its surface, stripes of browns, creams, and whites that shift constantly. The planet is like a storm painted onto a sphere, never still. These bands are made of gases, mostly hydrogen and helium, but colored by ammonia clouds and trace chemicals. Light reflects differently at different depths, creating alternating zones of pale white and rich brown, stretching endlessly around the planet. And then there is the great red spot, a storm larger than Earth, spinning for centuries. Its color changes, sometimes deep crimson, sometimes pale orange, as chemicals react in its clouds. It is not just a storm, it is a living canvas of atmospheric art. Seen through telescopes, Jupiter's colors look almost unreal, like brush strokes of an artist experimenting with shades of cream, tan, and rose. Yet these patterns are real, shaped by winds that roar faster than any hurricane on Earth. To gaze at Jupiter is to watch a painting that never dries, a sky in motion, a palette of chaos turned into beauty. Saturn's golden halo. Saturn is the planet of elegance. Its rings are iconic, but its color is just as striking. Seen from afar, Saturn glows with a golden hue, a soft yellow that feels warm, almost regal, against the darkness of space. This color comes from ammonia crystals and haze in its upper atmosphere, scattering sunlight into golden tones. Unlike the stormy reds of Jupiter, Saturn appears calmer, smoother, dressed in muted shades of cream and gold. Its rings, though made mostly of ice, reflect sunlight in silvery brightness, framing the planet like a crown. Together, Saturn and its rings are a cosmic work of jewelry, delicate, timeless, serene. What makes Saturn's gold so mesmerizing is its subtlety. It is not flashy, not harsh, it is gentle, like candlelight. A reminder that beauty in the universe is not only in violence or brilliance, but in grace. To see Saturn in a telescope glowing faintly gold is to see one of the purest symbols of wonder. No painting could capture it fully. It is beauty that exists only in the sky. The hidden colors of Venus. At first glance, Venus seems bright white in the night sky, the brightest planet visible to us. But that whiteness is deceptive. Beneath its thick clouds, Venus carries a world of hidden colors. Its atmosphere is shrouded in dense clouds of sulfuric acid, reflecting sunlight in brilliant white. But if you could descend, you would see yellows and browns, the muted tones of a suffocating greenhouse world. The beauty hides a brutal truth. a planet both dazzling and dangerous. Ultraviolet images reveal darker streaks across its clouds caused by unknown compounds. Scientists still puzzle over these markings. They are invisible to our eyes, but clear in other wavelengths, hinting at mysteries we cannot yet explain. Venus teaches us that color can conceal as much as it reveals. From afar, it glows like a beacon. Up close, it is a harsh, scorching place, painted in tones of fire and stone. Its brilliance in our sky has inspired myths for thousands of years, but its true face, hidden behind those clouds, reminds us that not all beauty is gentle. Ultraviolet, the glow of the invisible. Beyond what we can see, the universe glows in ultraviolet. It is light too energetic for our eyes, but stars and galaxies pour it out in abundance. To our vision, it is invisible. To telescopes, it is a hidden fire. Ultraviolet light reveals the youngest, hottest stars. These stars burn so fiercely that much of their energy is released in this unseen spectrum. In ultraviolet, galaxies look different. Their star-forming regions blaze brightly, like sparks hidden in the fog. Closer to home, our sun emits ultraviolet too. It is what gives us sunburns, what paints auroras in our skies. Our atmosphere filters much of it, protecting us, but in space it flows freely, marking every young star like a signature. Astronomers use ultraviolet to map the birthplaces of stars, to track the chemistry of galaxies, to read the hidden stories of light. Without it, we would miss the restless energy of cosmic youth. Ultraviolet is the reminder that what we see is only a fraction. The universe is glowing more fiercely than our eyes allow, burning in shades we cannot perceive, but which exist all the same. X-rays from dying stars. Imagine looking at the night sky with X-ray vision. What looks dark and calm to us suddenly bursts into violence. Exploding stars, black holes, neutron stars, all blazing with high-energy beams invisible to human sight. X-rays are born in extremes. They come from matter being torn apart, heated to millions of degrees as it spirals toward black holes or collides in stellar explosions. They are not gentle colors, they are sharp, fierce, almost dangerous light. Earth's atmosphere mercifully blocks X-rays from reaching us, protecting life. But telescopes in space like Chandra reveal a universe filled with them. Nebulae glow, galaxies shine, and every dead star seems to scream in X-rays across the void. To us, X-rays are only hospital machines or airport scanners, but in space they are the language of endings, the last cries of stars, written in invisible light. And perhaps that is why they fascinate us. They are proof that even when stars die, they do not fall silent. They keep speaking in higher, sharper voices that only special eyes can hear. Gamma rays, the universe's most violent light. If X-rays are intense, gamma rays are beyond imagination. They are the highest energy light known, produced only in the most extreme events. Collapsing stars, merging neutron stars, bursts that can outshine entire galaxies for seconds. Gamma-ray bursts are among the most mysterious signals we've found. For moments, they unleash more energy than the sun will in its whole life. If you could see them with your eyes, they would be terrifying flashes across the sky. But our eyes are blind to them. We rely on detectors orbiting above Earth, catching these brief, invisible sparks, and when we do, we know something immense has just happened far away. Gamma rays are not colors we can ever perceive. They are whispers of the universe at its most extreme. They tell us how stars die, how black holes form, how matter itself bends under gravity's weight. The thought is humbling, that in the darkness, flashes of unimaginable power erupt every day, unseen by us, yet shaping the very story of the cosmos. Infrared, the heat of the cosmos, If gamma rays are violence, infrared is gentleness. It is the light of warmth, the glow of embers, the slow radiation of dust and planets. It is not seen but felt, the same kind of light your skin feels as heat. Infrared reveals the hidden side of the universe. Cold clouds, invisible light, glow brightly in infrared. Telescopes like James Webb turn these shadows into luminous landscapes, showing us star nurseries where planets are forming. The beauty of infrared is that it slows everything down. Where visible light shows us fire, infrared shows us embers. Where galaxies look quiet, infrared reveals them alive with motion. It is the soft vision of the cosmos. Even the human body glows in infrared, every warm thing radiating light we cannot see. The universe too glows this way. Planets, asteroids, even distant galaxies sending out warmth into the dark. Infrared reminds us that not all colors are seen with eyes. Some are felt with skin, with warmth, with silence that carries its own quiet light. Radio waves, the silent rainbows. We cannot see. At the far end of the spectrum are radio waves. They are the longest, softest wavelengths of light, invisible, harmless, but carrying more of the universe's messages than any other. Radio telescopes reveal galaxies stretching like webs, pulsars ticking like clocks, black holes whispering with energy. The first great discovery of cosmic radio waves was static on a phone line, a faint hiss that turned out to be the echo of the universe itself. Unlike visible light, radio waves can travel enormous distances without fading. They pass through dust and gas, carrying information from the edges of the cosmos. They are the most patient of all colors, the long notes in the symphony of light. We use radio every day, in broadcasts, in phones, in signals. But in space, it is the color of quiet persistence. The slow language of galaxies, humming faintly across time. To lie under the night sky and imagine it alive with invisible radio waves is to feel the universe humming above you, a rain of signals always passing through us. Microwave light left from the beginning. And then, older than stars, older than galaxies, older than anything we know, there is the microwave afterglow of the Big Bang. It is the faintest whisper of light stretched thin over 13 billion years. Discovered by accident in the 1960s, this microwave background fills the entire sky. Wherever you point a radio dish, you find it. It is the leftover heat from when the universe was a newborn, still glowing from its own birth. To our eyes, it is invisible, but when mapped, it shows faint ripples, tiny differences in temperature that grew into galaxies, stars, and worlds. Without this ancient color, we would not exist. The cosmic microwave background is not just radiation. It is memory. It is the photograph of the universe as an infant, still glowing, still expanding, still carrying its first light into eternity. And every time you switch an old television to static, a tiny fraction of that hiss is this glow, this ancient microwave light reaching you from the dawn of time. Supernova explosions in rainbow bursts. When a massive star dies, it doesn't fade quietly. It erupts in a supernova, and an explosion so bright it can outshine an entire galaxy. And with that explosion comes color, poured across space in every shade imaginable. The gas and dust fly outward at tremendous speeds. Hydrogen glows red, oxygen shines green, calcium blue, sulfur yellow. The entire spectrum bursts into being like a firework, frozen in the sky for centuries. Some of these remnants are still visible to us. The Crab Nebula, the Veil Nebula, glowing shells of color, the aftermath of ancient deaths. To look at them is to see a star's life written in pigments across the heavens. The beauty hides the violence. Supernovae scatter the elements that build planets, oceans, even bones. Every shade we see is not only light, but material, the very ingredients of existence flung into space. Supernovae remind us that death in the cosmos is not the end. It is transformation, painted in colors that live on long after the star itself has gone. The green flash of a dying star's shockwave. Among the many strange effects of stellar death, there is one fleeting color that astronomers whisper about, the green flash. When shockwaves ripple through gas and dust, excited oxygen can glow emerald, a brief, eerie shimmer at the edge of destruction. This green glow is not common. It is fragile, lasting only as long as the wave of energy excites the atoms. Yet when caught, it is unforgettable, a spectral hue against the darkness, a final spark from a collapsing sun. It's a reminder that color is born in extremes. Green in space is unusual, which makes it haunting. It is the color of transition, of change, of something caught in the act of becoming something else. The next time you see pictures of supernova remnants glowing faintly green, remember that what you are seeing is energy itself, written briefly into light before fading. The green flash is not just beauty, it is a last heartbeat, painted into the void before silence returns. Aurora on planets across the universe. Here on Earth, we know auroras as curtains of green and purple dancing in polar skies, but auroras are not unique to us. Any planet with a magnetic field and atmosphere can host them, and they glow in colors as varied as the gases they pass through. On Earth, oxygen glows green, nitrogen purple, hydrogen red. On Jupiter, auroras blaze with ultraviolet unseen by our eyes. On Saturn, they glow faintly pink. Even Uranus and Neptune have their own auroral dances, painted in shades our eyes could never capture directly. Auroras are born when charged particles from the sun crash into atmospheres, funneled by magnetic fields. They are collisions turned into light, storms translated into curtains of fire across the night. To stand under one is to feel both small and deeply connected. For a moment, the sky itself feels alive, moving, changing, shimmering with unseen forces. And to imagine auroras on other worlds, different skies, different colors, it is to realize how infinite the universe's palette truly is. The golden rain of colliding neutron stars. Few events are more extraordinary than the collision of two neutron stars. When they spiral together, the energy released is staggering. Light, gravity waves, and elements scattered across space. And among those elements is gold, literal gold. For centuries, we wondered where the universe forged heavy metals. The answer is here, in these rare collisions. The light that follows glows in strange hues, from brilliant blue to deep red, shifting as new elements form. Hidden within is the golden rain, scattered into space, later to become part of planets. The kilonovae, as astronomers call them, glow for days, then fade. But what they leave behind lasts forever. Every ring, every coin, every fragment of gold on Earth was once created in such collisions. It is breathtaking to think that jewelry, treasure, and even the circuitry in our devices began as light and dust flung out of dying stars. The golden glow of neutron star collisions is not just a spectacle, it is the signature of creation itself. The strange blue of black hole accretion halves. Black holes are famous for being invisible. They swallow light, leaving only darkness. But just outside their edges, light explodes in colors so bright we can barely comprehend them. This comes from the accretion disk, the ring of matter spiraling inward. As gas falls toward the black hole, it is heated to millions of degrees. It glows in X-rays, ultraviolet, and sometimes visible blue. The glow is not gentle. It is the color of matter stretched, torn, screaming into energy. The blue we sometimes see is not the blue of calm seas. It is the blue of fire burning at its hottest, a fierce reminder that the most beautiful colors can be born from the most terrifying processes. Telescopes have captured hints of these glowing disks. They appear almost ghostly, arcs of light circling shadows. Around them, space bends, warps, twisting light itself into strange halos. To see blue near a black hole is to glimpse the edge of the possible, where color fights against gravity, where light resists being swallowed whole. The color of shadows in space. Shadows on Earth are never truly black. Sunlight scatters, bounces, fills them with hints of blue or gray. But in space, shadows are different. They are sharp, absolute, almost terrifying in their clarity. On the Moon, astronauts noticed that shadows were so dark they could almost disappear into them. Yet sometimes they had a strange glow from reflected light off the lunar dust. In the void, shadows play by new rules, revealing that color itself is relative to where light can reach. Imagine standing on an asteroid, half lit by the sun, half lost in blackness, so complete you cannot see your own hand. That black is not absence, it is contrast where color cannot cross. It feels heavy, endless, like a curtain between you and the universe beyond. And yet, these shadows are part of the painting too. They shape the brilliance of stars, the glow of nebulae, the shimmer of planets. Without them, the colors would lose their edge. The color of shadows in space is not simply black. It is the shape of silence, a reminder that light means nothing without its opposite. Why our eyes can only see a sliver of light. We like to think our vision is powerful, but in truth, it is narrow. The human eye detects only a small slice of the electromagnetic spectrum, what we call visible light, red through violet. That's all we're given. To bees, flowers glow with ultraviolet patterns. To snakes, the world shimmers with infrared heat. Even simple fish sometimes see a wider range than we do. We are not masters of sight. We are specialists, tuned only for the sun that warms our world. Why? Because evolution shaped our eyes for survival. We didn't need to see X-rays or gamma rays. We needed to see food, fire, the green of plants. So our vision narrowed to what was useful, leaving the rest of the universe hidden from us. It is humbling to realize what we call the sky is only a fragment. Most of the universe's colors are invisible. Our senses are too small, our eyes too limited. The cosmos is painted in rainbows we will never naturally see. And yet this limitation carries its own wonder. We live in a world where even the tiniest glimpse is enough to overwhelm us. Imagine what waits beyond. Telescopes as color translators. If our eyes cannot see the full universe, then telescopes become translators. They take invisible light, infrared, ultraviolet, X-ray, radio, and shift it into colors we can understand. In a way, they are cosmic storytellers, whispering truths in hues we can finally see. The Hubble Space Telescope, for instance, captured countless nebulae glowing in surreal reds and greens. But those colors are translations, chosen to represent gases and energies our eyes cannot detect. James Webb goes further, turning heat into brilliant imagery. What looks like art is actually science, coded into color. Some critics call these false colors, but astronomers prefer representative colors. They are not lies, they are ways of making the invisible visible. Each shade is a note in a symphony we were never meant to hear directly. In truth, every cosmic image you've seen, every glowing nebula, every golden galaxy, it was a human interpretation. They are accurate, yes, but also poetic. They are bridges between physics and imagination. Without telescopes, the universe would remain mostly black. With them, it becomes a painting we can finally step inside. Why NASA colors are often false, but true. When NASA releases images, people often ask, are those the real colors? The answer is both yes and no. They are not what your eyes would see standing there. But they are real, drawn from data and shifted into hues that reveal meaning. For example, hydrogen glows red, oxygen green, sulfur blue. Assigning those colors in photographs helps scientists map out what is happening. The colors are tools in ways to highlight chemistry, temperature, motion. Without them, we would miss the story entirely. Think of it like maps. A world map colors oceans blue, forests green, deserts yellow. Those aren't literal shades, but they help us understand. In the same way, cosmic colors are guides, not deceptions. And in a way, these colors are truer than what we could see. They reveal truths hidden to naked eyes, truths only instruments can detect. They are not exaggerations, and they are translations of reality into human language. So when you look at a NASA nebula glowing emerald and violet, you are not being shown fantasy. You are being shown truth in a dialect of light made just for us, the human brain and its cosmic palette. Even when light reaches us, color is not just physics. It is perception. The brain decides what we see. Two people may look at the same sunset and argue if it's orange or pink. Our minds paint as much as our eyes. In space imagery, this becomes even more striking. Our brains assign emotion to colors, red as fire, blue as calm, gold as warmth. So when we see these hues in galaxies, we don't just see data, we feel meaning. This is why cosmic photography touches us so deeply. We are not wired to think in parsecs and particle counts, but we are wired to feel something when we see color. The universe gives us signals and our brains translate them into wonder. Every cosmic image is therefore both outer truth and inner truth, the physics of light and the psychology of sight. Between the two lies the human experience of beauty, and perhaps that is why we keep looking up, why we keep painting the cosmos in shades we can hold, because when the brain sees color, it doesn't just see, it remembers, it dreams, it belongs. The color of shadows in space. Shadows on Earth are soft, tinted by scattered light. But in space, shadows are sharp and absolute, cutting reality into halves of brilliance and darkness. On the moon, astronauts noticed shadows so deep they seemed like holes in the ground. Yet at times they glimmered faintly from light bouncing off the dust. Space teaches us that shadows are not simply black. They are contrasts, areas where light cannot travel. On an asteroid or a distant moon, stepping into shadow would feel like stepping behind a curtain where no reflection, no color follows you. Yet these shadows define the glow of stars and planets. Without them, colors would have no edge. The universe needs darkness as much as it needs light, each shaping the other into beauty. So the color of shadows is not emptiness, it is silence. It is the quiet pause that makes the symphony of light feel whole. Why our eyes can only see a sliver of light. We imagine we see everything, but in truth, our eyes detect only a tiny sliver of the spectrum. Red through violet, just a thin band of the rainbow. Beyond it lies the universe, infrared warmth, ultraviolet fire, radio hums, X-ray storms. Other creatures see more. Bees follow ultraviolet trails on flowers. Snakes sense infrared heat in the dark. Birds see colors our minds cannot imagine. Compared to them, we are narrow-eyed, tuned only to the light of our sun. Evolution chose this slice because it was enough. Enough to hunt, enough to grow food, enough to live. We never needed gamma rays or microwaves. So the universe remained mostly hidden. painted in colors we were never designed to see. It is humbling to realize what we call the visible universe is really the invisible one, glimpsed through a narrow crack. Most of creation remains beyond our eyes, and yet even this fraction is enough to fill us with wonder. Imagine what waits in the unseen. Telescopes as color translators. If our eyes are limited, telescopes become our translators. They catch the light we cannot see and shift it into forms we can understand. They give shape to the invisible, turning whispers into colors. The Hubble Space Telescope painted nebulae in surreal reds and greens, not fantasy but translations. James Webb reveals glowing galaxies in infrared, showing us hidden stars inside dusty clouds. Each image is a bridge, data made visible, science made into art. Without these translations, the universe would remain grey and blank. With them, it becomes a living painting. What looks like dreamlike art in NASA releases is actually truth, shifted gently into a palette our minds can grasp. So, telescopes are not just machines, they are storytellers. They speak the language of light in ways our biology cannot. And through them, the cosmos finally steps into focus, color by color. Why NASA colors are often false, but true. When people see NASA's nebula photos, they ask, are those the real colors? The answer is both no, and deeply, yes. These are not what human eyes would see, but they are faithful translations of invisible truth. Hydrogen glows in reds, oxygen in green, sulfur in blue. Assigning those shades makes chemistry visible, maps star formation, and reveals hidden motion. It is not false, it is more than real, it is science coded in color. Think of a map. We don't color forests green and oceans blue because they literally glow that way from space. We color them to reveal meaning. NASA's images are maps of the heavens, every shade chosen to carry truth. And often, these colors are more accurate than our vision would be because they reveal what our eyes could never catch. They don't just show beauty, they show secrets. So the next time you see a nebula glowing purple or emerald, know you are seeing the universe speak in a dialect built just for us, the human brain and its cosmic palette. In the end, color is not just physics, it is perception. The brain decides what we see. Two people can look at the same sunset and disagree on whether it is orange or pink. Color is as much mind as it is light, and this means the universe's colors are half real, half remembered. When we see red, we don't just register photons. We feel warmth, we imagine fire. When we see blue, we sense calm. Our minds wrap emotion around physics, painting the cosmos twice. Cosmic photography touches us because of this. It's not just science, it's story. The hues trigger memories, symbols, meanings that connect us to the sky. Every image of a nebula or galaxy is therefore double, the outer truth of physics and the inner truth of feeling. Both are valid. Both make the universe what it is to us. And maybe that's why we keep looking up, because in the end, the universe doesn't just paint itself in color, it paints itself inside us too.